Question number 1A. So we are here on the simple trigonometric identities and equations. Okay, 1A. Prove that secant theta plus 1 equals to tangent theta sine theta over 1 minus cosine theta. Now, because this is the first time I'm introducing trigo to you all, right? I want you to remember this, okay? Always start from, as much as possible, most of the time, start from the more complicated expression. Understand? Always start from the more complicated expression. One of the students asked me why. Then the answer that I replied was, then you can do more work and simplify. Okay, so here's the way you do it. You say right hand side equals to tangent theta sine theta over 1 minus cosine theta. Now, after here, right, there can be a lot of pathway to get to the answer, which means you want to prove this is the left. You want to prove the right hand side goes to the left hand side. But so there can be many ways of doing it. But what you really need to do, there's no like, one student asked me, is there like a, is there like a cheat code, like a trick where I can get there? No, you just have to know what are the formulas to look out for, and then you just have to plug and play. So first is tangent theta is sine theta over cosine theta. Write that down. Okay, so don't look at my solution thinking like, why did the teacher do it this way? Honestly, I myself, when I look at this type of trigo proving, I also do not know how to do. I guess my way, I guess smartly, and along the way I try to solve. So I wouldn't know. I will just have to try. Understand? So sine theta times sine theta is sine square theta over cosine theta. Now we put over 1 minus cosine theta. And then this would be sine square theta over cosine theta times 1 over 1 minus cosine theta, correct? Now, if you can't see this, maybe I write like that for the students who cannot see. Then we flip it to times. This is just to facilitate your understanding of the working, so that I try not to skip step here. And then we have sine square theta over cosine theta times, cosine theta minus cosine square theta. Now, I'm sorry, can you erase this? I would love to leave it as cosine theta bracket 1 minus cosine theta. So again, actually, sometimes you will realize that you did an extra step, but later you realize you have to factorize. It's normal. So I'm going to teach you a way. Everyone put down your pen, because I already knew the answer. But let's think from the student perspective. Let's say the student reached until this point. You get stuck. Okay, put down your pen. What do you do? So you try to work. It's like you try to do from the right to the left, and then the left to the right. So it's like trying to meet. You understand? So you do your cheat. So let's say you are stuck. You start from the right hand side, you you are stuck here at sine square theta over cosine theta bracket 1 minus cosine theta bracket. Then you do from the left hand side. Okay, then you say, oh, okay, secant theta is 1 over cosine theta. So how I tell students to remember is the third alphabet is C, right? So 1 over cosine theta. Okay, plus 1. So this would be 1 plus cosine theta over cosine theta, right? Make the denominator the same. You follow? And then if you look here, right, you'll be like, my cosine theta, I'm going to highlight in purple, is right here. Is right here. My cosine theta is right here. So this one, I don't want to cancel because it's there already, right? That's the angle. Then how do I simplify the remaining here? Then you need to apply another trigo identity, that sine square theta plus cosine square theta equals to 1. This is a trigo identity. So sine square theta equals to 1 minus cosine square theta. You need to do this substitution. So then we write this as 1 minus cosine square theta over cosine theta. Now the cosine theta in purple stays there. That's the reason why I try to change the numerator again. Now take a look over here. 1 minus cosine square theta is a square minus b square, correct? Which is equals to a plus b, a minus b. And it's well noted that 1 is written as 1 to the power 2. So we can write our numerator as 1 minus 1 plus cosine theta, 1 minus cosine theta over cosine theta, bracket 1 minus cosine theta. Then you cancel these two, can see? And then we arrive at 1 plus cosine theta over cosine theta. Y'all got it? And then you see, this is exactly this one over here. So then we backtrack. That's the trick about doing it both ways, one from the left and one from the right. You try to meet at a certain point, but your working, you must still follow from the right hand side to the left hand side. You understand? You still have to follow that working. And then now you split these two fractions apart. So 1 over cosine theta will be secant theta plus 1, which is equals to LHS. And then you write the word proven. So this is for 1a over here. Everyone okay?
Square 0.
Yeah. 0 squared is just 0. Now 1b, everyone look here. Hence or otherwise, soft tangent theta sine theta over 1 minus cosine theta equals to 3 over 4 secant square theta for the angle. This time is in radian, between 0 and 2 pi radians inclusive. So I want you to take note of this. Can you see that this is exactly the same trigo expression as this? So then we replace secant theta plus 1 in here. So that equation transformed to secant theta plus 1 equals to 3 over 4 secant square theta. And look up first. This is important. Now if you see, this is important. If you see a trigo expression repeating itself, right, like secant theta, and then the square of itself, secant theta whole thing square, then remember, this is solving trigo equations in quadratic form. So this, you move everything to one side, we get 0 equals to 3 over 4 secant square theta minus secant theta minus 1. Okay, then we flip the equation. And here we will multiply throughout by 4 so that we get rid of the fraction. So we have 3 secant square theta minus 4 secant theta minus 4 equals to 0. And then here, for the sake of easier representation of our equation, you could do this, which I would advise you to, but for the stronger students, you can just straight away factorize. But I would propose that you do this is better. Let u be secant theta, so that this transforms to 3u squared minus 4u minus 4 equals to 0. But though that being said, right, to go back to my point earlier, you can straight away factorize out. So some of the students will do this in their working, perfectly fine. They will write like that. Okay, later on. Later first. So let's factorize this. We have u minus 2, 3u plus 2 equals to 0. So some students, instead of writing this one in blue, okay, what some students did was they did this. Instead of doing this, right, they straight away do this. Secant theta minus 2, 3 secant theta plus 2 equals 0. So you could do this way as well. It depends on your preference. But this might be a bit too abstract for students to see. It's a matter of preference. Okay, so now you solve for u. So u equals to 2 or u equals to minus 2 over 3. And then remember, we are not solving for u. We are just writing it as u so that we make the equation simpler for us to see and factorize. So now replace the u back with secant theta. So secant theta equals to 2 or secant theta equals to minus 2 over 3. And secant theta, look at the third alphabet, is C, right? So it's 1 over cosine theta equals to 2. So cosine theta equals to half over here. Now, the other one is 1 over cosine theta equals to minus 3 over 2. Sorry, minus 2 over 3, sorry. So cosine theta would be equals to minus 3 over 2. Now here I want you to write this NA, no answer. This means no answer. Do you all know why no answer? Let me explain this in red. Look here. Well, that's because cosine theta must be between minus 1 and 1 inclusive. Understand? However, minus 3 over 2 is not within the range. You understand? So there is no answer. You got it? You cannot find a theta so that cosine theta is minus 3 over 2. It's impossible. Because cosine theta is between minus 1 and 1. So now we solve for this. So alpha equals to cosine inverse of 1 over 2. So I want you to key in this now. Okay, cosine inverse of 1 over 2. And then you divide by pi. You will get 1/3. So this is pi over 3. You understand? And then now we do the ASTC. We have cosine to be positive. So ASTC is in the first and the fourth quadrant. And then to get the angle. So the first angle would be theta equals to pi over 3. And the second angle would be 2 pi minus pi over 3. So therefore, theta equals to pi over 3, 5 pi over 3. And you can leave your answer like this. It is fine. So that is the answer for question number 1 over here. Question number 2, we have to prove that cosecant to the power of 4x minus cotangent to the power of 4x equals to 2 cosecant square x minus 1. So here I would say the complicated expression is the left hand side here. Is that okay? And I want you to write down this identity. That's a to the power of 4 minus b to the power of 4. It's not really an identity, but if you can recognize that we are still using a square minus b square. So this is a square minus b square. A square plus b square. Got it? So what we're going to do now is we start from the left hand side. So left hand side equals to cosecant to the power of 4x minus cotangent to the power of 4x. So applying what I have written earlier, this will be cosecant square x minus cotangent square x, cosecant square x plus cotangent square x. So what I'm going to do next is for this expression over here, right? I'm going to rewrite it as cosecant square is 1 over sine square x. And then cotangent square x is minus cosine square x over sine square x. And then here is cosecant square x plus cotangent square x. And then we combine the numerator together. And 1 minus cosine square x is sine square x. You all understand that? From the trigo identity. Sine square x plus cosine square x equals to 1. So effectively, right, this is equals to 1. So I don't have to write that down anymore. So let me write down the one in yellow here, which is cosecant square x plus cotangent square x. So let me write down one of the, okay, so here to here, the identity, right, let me write down in blue, is sine square x plus cosine square x equals to 1. Now from here to here, I want you to write down 1 plus cotangent square x equals to cosecant square x, which means that cotangent square x equals to cosecant square x minus 1. So we have here to be cosecant square x plus cosecant square x minus 1, which is equals to 2 cosecant square x minus 1, which is equals to the right hand side, proven. Now you can write this in purple just for your info. There's an alternative way of showing that this is 1. Okay, this is another side. This is just additional stuff. So by the definition, right, over here, can you see that cotangent square x equals to cosecant square x minus 1? So then we have cosecant square x minus cotangent square x, right? To be equals to, you replace this in here, cosecant square x minus bracket cosecant square x minus 1 to be equals to 1. Understand? That's another way to do about it. So this is for 2a over here. Now moving on to 2b. Now 2b, solve the equation 6 tangent 2x plus 1 over cotangent 2x for the interval between 0 and 180 degrees inclusive. So 6 tangent 2x plus 1 equals to cotangent 2x. Now I want you to pause writing anything first. I want you to always remember, try to think of whether the trigo expression can be repeated. You know what I mean? Can you see a repeat of the trigo expression? So if you take a look here, right, I will convert cotangent 2x to 1 over tangent 2x. So objective in a trigo equation is to see whether or not you can repeat that trigo expression again and again. Here you see tangent 2x, and you also see tangent 2x again. So multiply throughout by tangent 2x, so we have 6 tangent square 2x plus tangent 2x equals to 1. Bring the 1 over to the left. So the reason for repeating the trigo expression tangent 2x is here is because you can see there's a square of the tangent 2x, there's just a tangent 2x. So this is actually quite commonly known as the solving trigo but in the quadratic manner. So again, it's now the standard SOP, standard procedure to solve this. So let u be tangent 2x. So we have 6u squared plus u minus 1 equals to 0. So factorizing this, we have 3u minus 1, 2u plus 1 equals to 0. So we solve u equals to 1 over 3 or u equals to minus half. So remember, don't stop here. We are not solving for u, we are solving for x. So replace tangent x, 2x, sorry, back in u. So tangent 2x equals to 1 over 3 or tangent 2x equals to minus 1 over 2. Then we find the basic angle alpha here. So this is in degree, right? So 3 dp for intermediate working for angles. So we have alpha, the basic angle equals to tangent inverse 1 over 3. So this angle here would be 18.435 degrees. Okay. So now we draw the ASTC. Tangent is positive because this is 1 over 3 is positive. So ASTC. So the line you draw in the first quadrant and the third quadrant. So now I'm going to do in blue. So we have 2x to be equals to 18.435 degrees. And then 180 degrees plus 18.435 degrees. Okay. Okay, let's now move to, so now we solve for x. So x would be equals to 1 dp, okay, 9.2 degrees. So I'm shortcutting 99.2 degrees, right, 1 dp. Now I want you to look up here. So the question I want to ask you is, right, do I go one more round? Like for example, we do one more round lah. So what I meant is, right, do we actually why don't we add another 360? We loop it one more round. So here, like that, we get this. Why don't we do that? So here, like this, we get this. Okay, it's a bit messy, I know, but the reason is, the thing is Trigo, you can always keep looping. But the reason why we never loop is because, right, you can do it at home later. The angles that you find will be out of the range. You understand what I'm talking about? You'll be out of the range stated here. But if the question write 360 degrees here, then you need to go one more round. So the tip here is you add 306. So I taught the sec 4s, right? Once you get the two angles, then either you add 360 to both of them to get the next answer, or you minus 360 to the both of them to get the other answer. You don't have to do the looping if it's confusing. So you add 360 to both, always two angles first, then minus 360 to both the angle. You all understand, right? Okay, let's move on to tangent 2x equals to half. So tangent 2x equals to minus half, sorry. So alpha equals to tangent inverse 1 over 2. So this is equals to, okay, remember to put in the positive, not the negative. So 3 dp, 26.565 degrees. And then we have our 2x to be equals to, okay, sorry, before that, ASTC now. Tangent is negative this time. So ASTC, it is in the second. So write the angle here, 26.565 degrees, and then it's in the fourth quadrant. So the basic angle 26.565 degrees, you notice is always the angle between the line that I have drawn and the horizontal x-axis. Okay, the horizontal axis. So let me write it in purple. So here the angle will be, so 2x, okay, 2x. So here is 2x. Got it? So 2x equals to 180 degree minus 26.565 degrees, or 360 degrees minus 26.565 degrees. Then we have x to be equals to 76.7 degree 1 dp, 166.7 degree 1 dp. And we are done with this question over here on question 2b. Pretty textbook style question. So again, right, let me emphasize one more. If you want to loop forward, you add 360 degrees. Always make sure you got the two angles first. Then if you don't like to do the looping, right, this works always. You add 360 degrees. Oh, not to this one, huh? Oh my god. I hope just now in my recording I did not say it's always to the original, huh? Sorry, huh? So you add 360 to both after you get the two angles, or you minus 360. Okay, not to this part here, and then you can add 360 degree here for both angles to generate the next two angle ahead, or you minus 360 degrees backwards to generate the previous two angles. Got it? So that is the whole idea for trigo solving. So hopefully you write down the working nicely. This is to serve as your revision.
This candidate because minus half right between -1 to like between 0 and 1.
Say again, sorry?
Wouldn't this this minus half value is possible because it's between the range
There's no range for tangent. The range of tangent is minus infinity to infinity. Understand? So to address the question, okay, this I'm just gonna write it down. Cosine x is bounded by -1 and 1. Tangent sine x is bounded by -1 and 1. But tangent x itself, right? There's no bound. If you look at the tangent graph, right? Where's the bound? It's from minus infinity to infinity. No bound for tangent. So tangent is more special. So take care of tangent. Like just now the period, right? I said pi over something, right? And also take care that the tangent, the amplitude is different. There's no amplitude to talk about. It's negative infinity to infinity. Can? So yeah, they won't test that one. Tangent no shift graph. Don't worry. Only sine and cosine. Amplitude infinity. Period is still pi over 2 for tangent graph. Got it? Question number 3. Show that 2 minus 2 secant square x over 1 plus cosine x, 1 minus cosine x equals to minus 2 secant square x. So like I mentioned in the previous week lesson, you always start from the complicated side as much as possible. So you will say LHS. So what did I write that time? I write in black, right? Okay, let me write in black. So we say left hand side LHS equals to 2 minus 2 secant square x over 1 plus cosine x, 1 minus cosine x. Now, like I said, as I've always been telling the students is that you will know what is the next step, but that's normal. So you just do what you can. So what I would do, right, is I would take out minus 2 from the numerator. So I will get secant square x minus 1. And then I will expand the denominator. That will give me 1 minus cosine square x. And based on this trigo identity, we know that 1 plus tangent square x equals to secant square x. So secant square x would be secant square x minus 1 would be equals to tangent square x. So I would replace this with tangent square x. So you will always need to refer back to the trigo formula sheet. So this is minus 2 tangent square x over. Now here we have, so this is for this part. Now here again from your trigo formula, sine square x plus cosine square x equals to 1. So we have sine square x equals to 1 minus cosine square x. So I will replace 1 minus cosine square x with sine square x. And we noted that tangent x is sine x over cosine x, right? So tangent square x would be equals to sine square x over cosine square x. So I will replace this with this right here. So it will be minus 2 bracket sine square x over cosine square x divided by sine square x. So it will be minus 2 sine square x over cosine square x divided by sine square x, and then change it to times. Cancel the sine square x, and then we will have minus 2 over cosine square x, which here I'm actually writing out the working in detail, but you need not present it like me if you already know your stuff. So 1 over cosine square x is minus 2 secant square x. So I can write, so this is equals to RHS, should. So one of the thing that you must know is secant x, the third alphabet is C, so it's 1 over C cosine x. So secant square x is 1 over cosine square x. Basically, you square both sides. Can I hope that I'm detailed enough for y'all. Any questions so far? All right, let's move on to part 2. So this question, this type of question did came out in this year O-level AMF, quite typical. So first they will ask you to show a trigo proving, and then next you will use that trigo proving to solve a trigo equation in 3 part 2 here. So hence, find in radian, where x is between minus pi and pi radian inclusive, the values of x in radian. So remember to change your calculator to radian mode, for which 2 minus 2 secant square over 1 plus cosine x, 1 minus cosine x, which is exactly this one over here, okay, equals to 4 tangent x. So we can just simply, maybe I don't skip step, so let me copy down this equation here. So let's do that. 2 minus 2 secant square x over 1 plus cosine x, 1 minus cosine x equals to 4 tangent x. And then we replace this, since we have shown that this is minus 2 secant square x, right? So we write minus 2 secant square x equals to 4 tangent x. Any questions so far? Now I'm going to give you an extension. You can write this down if you want, but that is for your own reference, because I think this is a possible question that could come out. So if they write like that, right? You can write it down, possible extension. If they ask you to solve this, then first you must recognize that this is equals to minus 4 secant square x. Do you all understand where it is coming from? No? Okay. So sometimes they might not be so nice to give you the exact same trigo expression. So what you must recognize is that if I multiply both sides here by 2, do you realize that multiplying 2 to this give me this? Do you realize? Okay. Times 2 on both sides will give me 4 minus 4 secant square x. Understand? So that is the whole idea, which will give me minus 4 secant square x. So if I were to write it out for you all, if I multiply 2 on both sides, right, I will get 4 minus 4 secant square x over 1 plus cosine x, 1 minus cosine x equals to minus 4 secant square x. Sometimes the question will play around with all this constant. Okay, anyway, for those who are watching a recording and for those in class, I'm just giving another type of question. It's not the question that we are doing now, but it could be a possible type of extension. Not say extension, this is quite common. You all understand? It's like playing with the constant. Okay, now let's come back to this. So again, we have the trigo identity here, that is 1 plus tangent square x equals to secant square x. So I will replace the secant square x with 1 plus tangent square x. So it will be minus 2 bracket 1 plus tangent square x equals to 4 tangent x. Now, I'm very surprised that this did not come out in this year O-level, if my memory serves me right. So I'm going to predict the question again because I predicted some of the O-level questions correctly. And it did come out. So this one didn't come out in O-level 2024. So I'm going to put a star here. I think it might come out this year. Next year, sorry. You all know what I'm doing here or not? Do you know why I replaced the secant square x with 1 plus tangent square x? Is because, pay attention, I want the tangent x trigo expression to keep appearing. And why do I want that? Let's expand this and then I will elaborate to you. I want to move everything to one side. And then I flip the equation. So I want the tangent x to appear, especially the one with the tangent x holding square, so that I can do this, let u be tangent x. I'm quite surprised that some students just can't seem to get over this barrier. And then you have u square plus 4u. Sorry, I think I make a mistake somewhere. Did I? Oh my god, this is a mistake. Lucky I see. Minus 2. Okay, sorry. So 2. 2. Okay, that's my mistake. So then let u be tangent x. The reason why I force out tangent x, right, the expression throughout, you must always remember this. It's either this type of question or the other, where this is quite common. And it will appear in your weighted assessment one. Because it's the kind of question that only the teacher can set. If you are stuck, always ask yourself this. This is very important. I'll repeat it again. Try, if possible, to force out the same trigo expression. And then you simplify it into quadratic equation. You understand? So that is the whole idea why I replace the secant square x with 1 plus tangent square x. Do you understand? So that I force out the tangent x. So now this is what I call, the way I call this is the quadratic trigo equation. So I'll divide by 2 throughout. So u square plus 2u plus 1 equals to 0. By the way, I will guarantee that this will appear in your WA next year. One way or another, they will always test this. And given the fact that this year O-level wasn't tested, right, I predict that this one will come out. Okay? So factorizing this, we solve for u. U equals to minus 1. But remember, some students actually stop here. We are not solving for u. We are solving for x. So replace the tangent x back inside. And recall, because I know math, there's so much content, right? I told you before that if it's an integer value, you draw the graph, but not for tangent. So tangent, you straight away find the basic angle alpha, take the tangent inverse of the positive value, which is 1. So in your calculator, you will get pi over 4. Okay, for tangent, you don't have to draw a graph. Then now, we will do the ASTC. So tangent is negative, right? So it will be in the second and the fourth quadrant. So the basic angle is pi over 4 over here and here, of which my angle for x would be pi minus pi over 4. Okay, and okay, minus pi over 4. Some student got asked me before, teacher, why you don't want to consider this angle here in purple? 2 pi minus pi over 4. Because in my solution that time, I did not include this. Anyway, I will tell the student, let's just include it. It's fine. So, so what I'm going to do here is x will be equals to 3 pi over 4 minus pi over 4, and then 7 pi over 4. Now we reject the one in purple because, let's come back to this range, because the question asked between minus pi and pi. So the purple is rejected. You understand that? That's why if you are fast enough, you don't even have to write the working for this part here. It is acceptable. But I mean, this is my working, but can I do it the student way? Suggested student way, sorry. Because since I taught this, suggested students way, because this is, I'm sorry, this is the way I do it, and I think I don't like it. So I want to do the suggested student way. Okay, so the suggested student way, I want you to find the first two angles normally. Okay, I'm just going to give an alternative. So you will do the standard way. So you'll find the two positive angle. So we have the quadrant, in the second quadrant pi over 4, and in the fourth quadrant pi over 4. Okay, I'm going to do the student way. So first angle, it will be pi minus pi over 4. Second angle would be, because this is what most students will do, I realized over the years. Because not a lot of students will follow this way unless they really understand what they are doing in depth. So the second angle would be 2 pi minus pi over 4. So this is what most students will give when I mark the paper. And then they will say, oh, x is equals to 3 pi over 4 and then 7 pi over 4. And then they stop here and then they lose a mark. So why I write like that, right, is because if you follow my way, I can guarantee you that you will get full marks. That is my assurance to you. So what you need to do is, if you don't like to do the looping, right, let me teach you this way. I'm going to move this down. And so you figure out your working yourself. This is a trick. You loop it back minus 2 pi. Minus 2 pi. Okay, if you are very kiasu, which you should be, you add 2 pi in front. If let's say you really don't know what's happening, you add 2 pi and add 2 pi in front, because everything is periodic. So this answer here, after minusing 2 pi would be minus 5 pi over 4. Am I correct? Yes, I'm correct. Yeah. And then here, 7 pi over 4 minus 2 pi would be minus pi over 4. Okay, now we loop in front. 3 pi over 4 plus 2 pi would be, please let me know if my arithmetic is wrong, which I don't think so. It will be, suddenly my brain cannot function. 11 pi over 4. And then this would be 15 pi over 4. Did I get it correct? Yes, I get it correct. And you will realize that I'm going to write the rejection in purple. I will reject this. Okay, I will reject this. I will reject this. I will reject this. Precisely because these rejected values, right, it falls out of the range from minus pi to pi. Okay, this is the surest way to make sure you have all possible trigo answers, because students will always miss out the value. But side note, this working, while it's good, is time consuming, but it is still good enough if you want to get the full credit without ever going through the, looping again. So long as you find the two angles highlighted in yellow, okay, you are good to go. Understand? But I want to caution one thing. This one, everyone must pay attention, because it's the mistake that students make. This x, right, it must be exactly what is represented here, okay? In this practice question, I would not be able to illustrate much, but when you do the looping of minus 2 pi and plus 2 pi, right, it must be exactly what is inside. the trigo, the input here. You understand or not? Okay, I shall not elaborate much on this because I don't think that it will align with what I'm trying to explain. So I feel that this will suffice in terms of explanation. But yeah. So the more shortcut way, if you truly understand what's going on, you write like that. If not, if you think that you are afraid that you will lose marks, then you do my way. The trick. Add 2 pi and minus 2 pi from the two angles that you're going to find. So these two angles highlighted in yellow will be the one that you derive from the ASTC. Subsequent angles is always periodic by 2 pi ahead or minus 2 pi back. And that would sum up for question number 3. Question number 4. Prove that 1 over 3 tangent square theta plus 3 equals to cosine square theta over 3. So again, we start from left hand side because it's more complicated. So again, I would advise students is that, to be honest, you don't know what to do, so do exactly what you can. We take out 3, and then, okay, let me write down for you, okay? Only in this tutorial, we noted that 1 plus tangent square theta equals to secant square theta. Yeah. So we have to replace this with this. That's it. So it's 1 over. So always refer to your Trigo formula sheet. So this is just 1 over secant square theta. I wrote it earlier already. Is 1 over cosine square theta. Always remember to look at the third alphabet, C. And then you have 1 over 3 over cosine square theta. That will give you cosine square theta over 3, which is equals to RHS, and we have proved. So this is a short proving question on question number 4. Is that okay? Moving on to question number 5. Question number 5, again, will come out in your WA for sure. So try to pay attention. Angles A and B are in the same quadrant such that sine A equals to 3 over 5 and cosine B equals to minus 7 over 25. Okay, so when you do this type of question, right, step 1, mentioned it before, identify which quadrant A and B are in through elimination. So identify which quadrant A and B are in through elimination. So first step you would need to do is sine A is positive, right? So A is in the first and second quadrant. And then we have cosine B is negative. So cosine B, it will be, B means, maybe I should be more precise here. Okay, let me write down more. A is in, okay. So B is in, cosine B is negative, so it will be in the second and third quadrant. So, and then the question tells you that A and B are in the same quadrant, right? So by elimination, right, you can realize that A and B are both in the second quadrant. Do you know why I decided to be take so long to write this? Is because if you identify the wrong quadrant, 5 marks gone. And out of 30 or 35, depending on your test, right? That's it. So you really need to identify the right quadrant, because math is built upon one another. Now we have identified that A and B are in the second quadrant, right? Now we draw the ASTC. Okay, later I'm going to write something in red. So they are both in the second quadrant. So it's okay to write this as A, okay? Although technically they are not angle A and B, it's fine, you know. It's just a way of saying it. But I want all of you to write this, which I can tell you every year the student just make mistake despite reminding them just one day before the WA, you know. Okay, it's like, I don't know why, but always account for negative axis. Okay, I'm going to write this in red, meaning, so sine A is 3 over 5, right? So, okay, the red one later I tell you where. So O over H, I shall not go through this, it's sec 2 Tuakaso. Okay, and by the Pythagoras theorem, right, you would have found that this is 4. Okay, again, you all figure this out by yourself. But take note that this is in the negative x-axis, so it's minus 4 here. Okay. Now what about cosine B? Cosine B is minus 7 over 25, right? So then here you look up, you need to allocate minus to the, you need to know which minus to give. So in this case, I will give the minus to the 7 because A over H. Let me tell you why. So minus 7 because the adjacent to the angle B is in the negative x-axis. Okay. And then the hypotenuse is 25. So we have this to be 24. Got it? By the Pythagoras theorem again. So once you have this ASTC drawn, right, the rest of the answer becomes very easy. Actually, I would say this is the key. You get this right, you get the full marks. Yeah. So please always account for the negative axis. It is one of the mistakes that students always make. So let me highlight in yellow where it's here. If you can highlight, that's even better. So long as the sides of the right angle triangle is in that axis highlighted in yellow, right? If you take note that this is a negative x-axis, this is a negative y-axis. You can think of it as sec 2 Tuakaso but with negative length. Okay? And actually, it has along the way when I'm teaching y'all, I'm covering the key concept. Hypotenuse in purple, always positive, write it down. Hypotenuse is always positive. So you don't have to worry about that. So actually in this regard, right, you will realize that, hey, if my cosine B is negative 7 over 25, right, knowing that hypotenuse 25 is always positive, I will allocate the negative to the 7. So now we find tangent A for the first part of the question. So tangent A would be equals to opposite over adjacent. So 3 over minus 4. So that is 2 marks. Although very simple, right? You see just a fraction, 2 marks, but you can see the work that we have done along the way. Now part 2, cosecant B. Now remember to look at the third alphabet, that is S, which means this is 1 over sine B. So 1 over, what is sine B? So sine B is O over H, which is 24 over 25. Which is equals to 25 over 24. So that is for question number 5 over here. Let's move to question number 6. Again, a proving trigo question. Show that cosine A bracket 1 over 1 plus sine A minus 1 over 1 minus sine A bracket can be written in the form of k times tangent A, and then find the value of k, right? So what we do is, here, we leave the cosine A outside. Then we just combine these two fractions normally by making denominator the same. So I will multiply. Okay, let me highlight differently. So this fraction here, right, I'll multiply the top and bottom by 1 minus sine A. So that is the fraction in yellow. Minus, now this fraction in blue, I will multiply the top and bottom by 1 plus sine A. And now I will combine the two fractions together. So I will have 1 minus sine A minus 1 minus sine A over. Now I'll x, okay, maybe I don't skip step. The denominator is 1 plus sine A, 1 minus sine A. And then I will simplify the numerator first, which will give me minus 2 sine A over. Now this is the expanding the denominator will give me 1 minus sine square A. Got it? And here is how if you do it long enough, right, like practice makes perfect. You notice there's a cosine A here, and you're wondering if you can cancel that out, which is possible, but you need to rewrite this. Okay, noted that sine square A plus cosine square A equals to 1, right? So sine square A equals to, cosine square A would be equals to 1 minus sine square A. So I will replace this in here. So I have cosine A bracket minus 2 sine A over cosine square A. So cancelling this, we have minus 2 sine A over cosine A. Now if I want to write it to you, for you to see it clearly, so this minus 2 times sine A over cosine A, which is equals to minus 2 tangent A. So they're looking for what is k, right? K times tangent A, this is minus 2 times tangent A, so therefore k equals to minus 2. Got it? So that's for question number 6 over here. Okay, moving on to question number 7. Okay, 7 part I. Given that theta is acute. So what this means is that theta is in the first quadrant right now. And surprisingly, some students couldn't see this. And sine theta equals to C. Let me write it down in the way that student can see. So sine theta equals to C over 1. So in fact, this is just O over H. Okay, C is the opposite. 1 is the hypotenuse. So if you draw your ASTC now, okay, so theta is in the first quadrant. So O is C, hypotenuse is 1. So suppose we let this be x. So by the Pythagoras theorem, x squared plus c squared equals to 1 squared. So this is just my working. So then x squared equals to 1 minus c squared. So x equals to, now as I understand, right, we usually what your E-math teacher taught you was that you put a plus minus in front here, but we don't because we are in the positive x-axis. You understand? So this will just be square root 1 minus c squared. So it's just the Pythagoras theorem application here. Now with that, we come to 7 part I. So let me give a while for the students to copy finish. I need a show of hand in case some of you did not internalize the recording. This is cosine theta. Show of hand if you want me to explain this to you. If not, I'm going to skip it over. Why sine 90 minus theta is cosine theta? Don't be shy if you don't know. Okay, if everyone knows it, that's good. So sine 90 degree minus theta is equals to cosine theta. And cosine theta, based on this, using your sec 2, right, is A over H. So it's just square root 1 minus c squared. So that's for part I. Part 2. Cosecant theta is equals to 1 over, again the third alphabet, sine theta. So this is just 1 over C. Quite easy actually, because sine theta is C, as given from the question. Now part 3, tangent theta. Tangent theta is easier as well. So it's just O over A, which means it is just C over square root 1 minus C squared. Got it? And we are done with question 7 over here. Okay, now moving on to question number 8. Now question number 8, right? We have solve the trigo equation sine 2x equals to cosine 2x for x between 0 and 360 degrees inclusive. So I want you to write this down now. Objective in trigo equation is to make it as sine something equals to a constant, you know. That's the objective. Cosine something equals to a constant. This is important tip, or tangent something equals to a constant. So this is something that you can copy, which is quite important. So when you have a complicated trigo equation, right, doesn't matter what the exam give you, so long as you can reduce the trigo equation to sine something equals to a constant, cosine something equals to a constant, or tangent something equals to a constant, that will do. So here I will divide both sides by cosine 2x. So left hand side is just tangent 2x, right hand side equals to 1. You understand so far? And again, let me reiterate, I did mention integer value, you draw a graph, right? That is only applicable for sine and cosine. For tangent, straight away, you take the tangent inverse of 1. So this will be equals to 45 degrees. Remember to switch your calculator to angle. So now we have tangent positive. So we have it in the first and the third quadrant. And then we write down the basic angle 45 degrees. So the first angle here, so 2x equals to 45 degrees. And then the second angle will be equals to 225 degrees. So 180 degree plus 45 degrees. Got it? When you're done, show me that you put down your pen, because I got next important thing to say. This is the example that I want to go through. Okay? Put down your pen when you can. This is important. So remember I taught you about finding the two angles first, and then you add 2 pi or 360 degrees to find the angle ahead, and minus 2 pi or minus 360 degrees to get the angle before. Remember that? So this is only applicable. You see this 2x, right? You must do it at this portion here when it's at 2x. So this is the part where you actually do my method. So you add 360 degrees forward. Only at this level highlighted here, 2x. What I'm trying to say is some students, they divide by 2 already. So this is the wrong method. Some students, they divide by 2 already, right? Okay, I'm going to write. I don't want to write neatly because this is not needed. So 225 divided by 2 is 112.5, I think. So some students, they add 360 here. This is wrong. Okay, you're not supposed to add 360 here. You're supposed to do it at where 2x, because tangent 2x at this part of the working here. You understand? So I caution you already what the students' mistakes were. So you add 360 degrees, this will be 405 degrees. Okay, and then 225 plus 360 is 585 degrees. And then now you divide throughout by 2. The reason why I decided not to minus 360, right? Because I look at the question, the question, they are only asking for non-negative angles. So now x will be equals to 22.5 degrees, 112.5 degrees, 202.5 degrees, and 292.5 degrees after dividing throughout by 2. And we are done with this question over here. So that's about it. Question number 9. We have solved the equation sine 252 degrees minus x equals to minus 0.347 for the angles between, this time is excluding the n angles, 0 and 360 degrees. So we have, write it down. So sine 252 degrees minus x equals to minus 0.347. And then start to find the basic angle. We take the sine inverse of the positive value without the minus. Now, if you do this, let me do a quick calculator evaluation. We get 20.304 degrees. I will write non-rounded angles to 3dp. After which, we have sine to be negative, so it would mean that the angle is in the third and the fourth quadrant. So the basic angle is 20.304 degree, 20.304 degree. And here is the evaluation. So we have, remember, this 252 minus x. So 252 degree minus x equals to 180 plus 20.304 degree. Okay, and then we have, okay, this I am doing the student method already. I'm not doing my way of doing, which is observe quickly and write down the answer without the need to reject. So I'm doing the student way. 360 degree minus 20.304 degree. Oh, by the way, for the students who think that you are comfortable with my initial way of doing it, right, that is you observe and you get the angles without rejecting them, please go ahead. So, so what happens here is we solve for x. Okay, if we solve for x, right? Okay, let's keep it as minus x. Okay, I tell you what, I'm going to shift this to the right. Later you will know why. This is the type of question that will definitely catch your off guard, for sure. So minus x, we bring the 252 over. So I'm just going to evaluate it out because I don't have space to write. Basically, you bring the 252 over, you will get minus, can I write in purple? Minus 51.696 degree. And then you bring the 252 over, you will get 87.696 degree. Okay, and then you multiply throughout by minus, you will have 51.696 degree. Okay, so I actually intentionally selected the question to be of a different variety, and then you multiply by minus so that you know how to tackle the question when required. So minus 87.696 degree. Now the question is, you need to reject the negative 87.696 degree. Why? Because the question asks only for the positive angles. So you need to reject this. Then the next question you will ask is this the only answer? Because it falls within the positive range, right? From 0 to 360 degrees. So if you use my method and you don't feel like observing, you're just brain dead, you just want to do the question, you can do my way. And then at the end, especially for Trigo equation, you need to ask yourself whether you have given all the possible answers, because the teachers and the examiners are very keen to mark, especially if I'm marking, right? I will go to the end and I will know. I will mark you all down very quickly. if I'm the marker, I will look at your last angle and I will know how much mark to deduct. So here you will realize, okay, I would probably not add 360 to these two angles here, because anything ahead will give me negative. So what I would do is I would minus 360 degrees. Okay, this is observing. So by minusing 360 degrees, so minus 360 degrees, okay? So teacher is being lazy, okay? I don't want to write out the arithmetic. You will get minus 159.696 degree, and then 360 minus, oh, then that will be just be minus 20.304 degrees, understand? And then now you do the same sec1 linear equation. You bring the 252 over. Okay, you bring the 252 over. This will be minus 411.696 degree. And then this would be minus 272.304 degree. And then now you multiply minus throughout. So it will be 411.696 degree and 272.304 degrees. And then, hey, you know what to reject. You want to reject the 411 degree, right? Because it's out of the range. So then the two answers will be the one in yellow. So hence, x would be equals to 51.7 degree. Remember, angle is to 1 dp. And then 272.3 degrees. And you're done. So my way will guarantee you full credit. Suppose if you actually follow my way like what I have taught you just now. Understand? I would admit that it's not that easy, alright? It's not that easy based on this question because this is 252 minus x. You can't really see the range properly if you realize, you know where I'm coming from. You can't really determine how to one shot and then find the answer. It is not, even for me as a tutor, I would not be able to see it that easily because this is 252 minus x. So this question is trying to illustrate that. So if you do it my way, that would help. Understand? This question will be 2 marks most students will get. Especially they will forget. They will forget to write this angle here. So Trigo equation, look at your angles that you get at the end and then you ask yourself whether you have given all the possible angles. Okay? Question number 10. Prove that sine x over secant x plus 1 plus sine x over secant x minus 1 equals to 2 cotangent x. So we start from the left hand side, the more complicated side. So we have sine x over secant x plus 1 plus sine x over secant x minus 1. So here we just combine the fraction by making the denominator the same. For this fraction over here, we will multiply the top and bottom by secant x minus 1. For this fraction over here, we will multiply the top and bottom by secant x plus 1. And then slowly, this is 1 over cosine x minus 1. So here I'm just changing the secant x to 1 over cosine x minus 1. And then I'll expand the denominator is secant x minus 1. Plus, same thing, I change the secant x in the numerator to 1 over cosine x, okay? With plus 1. And then I'll expand the denominator here as well. Secant x minus 1. And I'm going to multiply the sine x in. So we have sine x over cosine x minus sine x over secant x minus 1 plus multiply the sine x inside So sine x over cosine x plus sine x over secant x minus 1. So if you add the two numerators together, but before that, sine x over cosine is tangent x. Okay? Tangent x. And then you add both of them together, you will have 2 tangent x. And do you remember this trigo identity? So tangent 1 plus tangent square x equals to secant square x. So secant square x minus 1 equals to tangent square x. So replace this with tangent square x. We get 2 tangent x over tangent square x. So this becomes 2 over tangent x, which is equivalent to 2 cotangent x, which is equals to right hand side. Proved. So that is for 10 part I over here. Now moving on to 10 part 2. Now, if you notice, right, this type of question will come out in your test and exam. This is identical to this. So maybe let me skip step a bit. So let me replace the blue with the one in yellow, okay, in this equation over here. So we have 2 cotangent x equals to 2 tangent x over 3. And what I'm going to do here is the cotangent x. 2 cotangent x will be 2 over tangent x equals to 2 tangent x over 3. So again, the whole idea is, right, rather than telling you the answer, try to always remember this in trigo equation, force out the same trigo expression as much as possible, okay? That's one of the guidelines that you can follow. And then you have a fraction equals to a fraction, you cross multiply them, you will have 6 equals to 2 tangent square x. So dividing the 2 over and rewriting, we have tangent square x equals to 3. Because 6 divided by 2 is 3. And then we have tangent x equals to plus minus square root 3. So I will write it as tangent x equals to square root 3 or tangent x equals to minus square root 3. Okay, now I'll find the basic angle, which is tangent inverse square root 3, which is equals to pi over 3 for this. Same goes for this. Basic angle is tangent inverse square root 3. Take the non-negative, remove the minus when you do the inverse, when you put it inside, pi over 3 as well. Just a side note for your is that it isn't that easy to see that it's pi over 3. So I want you to do it in your calculator. You key in tangent inverse square root 3. Your calculator won't give you pi over 3. So you need to divide by pi. Okay, let me put it here. You can do it in your calculator. Divide by pi to know what fraction to put. So after you key in tangent inverse square root 3, right, and you divide by pi, you will get 1 over 3 in your calculator. So that is how you get the exact form. So what we're going to do next is everything is in radian. So this is in the first and the third quadrant because tangent is positive. So we have pi over 3 here and pi over 3 here. So my answer here would be x is equals to pi over 3 and pi plus pi over 3. Okay, now the other one, tangent is negative. So we are in the second and the fourth quadrant. You got it? So we have pi over 3 here and pi over 3 here. So then the angle here would be pi minus pi over 3, 2 pi minus pi over 3. So later whether we need to add or minus the 360 degrees or equivalently 2 pi, right, it remains to be seen. So here I have to evaluate it out. I really want to see the value here. So pi over 3 is 1.0472. I'll write as pi SF for radian. And then pi plus pi over 3 is 4.1888. Here pi minus pi over 3 is 2.0944. And 2 pi minus pi over 3 is 5.2360. Okay, and now take note here, we want it to be between 0 and 4, right? So I would say that this is so-called your pencil working. Okay, maybe let me write it in black. But it doesn't really matter lah. Okay, let's just leave it. Did the question ask in exact form? Oh, the question did ask in exact form. Exact solution. So you cannot write it like this. So maybe let me side comment. This is in black. This is in red, okay? This is in pencil. Pencil working. So that I know that, hey, the values of x that fall within this range from 0 to 4 is pi over 3, which is 1.0472, and pi minus pi over 3, which is 2.0944. You understand? So I have to reject this one, which is a 4.1888. It falls out of the range from 0 to 4. And I have to reject this one because this 5.2360, it falls out of the range from 0 to 4. So therefore, the answer will just be x equals to pi over 3, and pi minus pi over 3 would just be equals to 2 pi over 3. And we are done with this question over here. Can? Now, although seemingly easy just because I'm explaining and doing it, right? But when you really put the work into it, it's different story. So just make sure to know how I have done it and then apply the things I have taught you and the tricks, and you should be fine. Can? Maybe I should circle this and write in red, in pencil. Great. Question 11. Given that theta is obtuse and that sine theta equals to 1 over square root 3, so from here, right, you can say that theta is in the second quadrant. Okay. If you can see my solution, right, I'm going to upload this in the learning management system because I think the solution that was given is a bit too summarized. So you all can refer to it if in case you all lose your notes. So theta is in the second quadrant. It's very important to identify which theta, where theta is in which quadrant. Now sine theta is 1 over square root 3, right? So you can write down here, O is 1, square root 3 is H. So we draw the ASTC, and then you can say that this is theta. Okay, you can think about it that way. So this is theta. So O is 1, square root 3 is the hypotenuse. So this is x. So do the Pythagoras theorem. But if you can identify it quickly, right, then that's good. So x squared plus 1 squared equals to square root 3 whole thing square. So x squared equals to 3 minus 1. So x squared equals to 2. So x equals to, here, minus square root 2, people, because we are in the negative axis. By the way, I tell you, I don't know why. Okay, I'm gonna say this one more time. Year in, year out, students just keep forgetting this. I don't know why. And they lose 5 marks. Just like that, And then they lose the marks because of harder question, and then they fail. Just trust me. Remember the negative axis when it comes to this type of quadrant question. So you should, I'm gonna write in red. Okay, let me take the effort to actually, write in red, just so that, you know, this is the mistakes that you all always make from yearly observation. Minus square root 2, you understand? Okay, so now we have the right angle triangle. Most of the work is done. What we're going to do is, the question now asks, express without the use of a calculator 1 over sine theta minus cosine theta. Okay, this is pencil working, by the way. Pencil working. Okay, pencil. Although you can present it as part of a solution, that's fine. So 1 over sine theta minus cosine theta. This is actually equals to, okay, sine theta is what? Sine theta is 1 over square root 3. I mean, that's given from the example here, right? Quite nice of them. So what we need to do is, why we even do the right angle triangle in the ASTC is because we need to use it to derive cosine theta. So cosine theta is the one highlighted in yellow. Look here, A over H, which is, okay, I'll write in red for your convenience, minus square root 2 over square root 3. So this is 1 over minus me is sec 1. 1 plus square root 2 over square root 3. Okay, and we have square root 3 over 1 plus square root 2. And how do you actually make it into this form, right? Is we need to, let's go back to our sets. We rationalize. Times 1 minus square root 2 over 1 minus square root 2. So then we have square root 3 minus square root 6 over 1 minus 2. Am I very fast? I leave it to you all to work out the sets yourself, okay? So it's square root 3 minus square root 6 over minus 1. That will give me square root 6 minus square root 3. And yeah, we are done over here with this question over here on question number 11. Question number 12, part I. Prove that 2 minus 2 cosine square theta over cosine square theta equals to 2 tangent square theta. So we have, again, start from the complicated side, LHS left hand side, 2 minus 2 cosine square theta over cosine square theta. So we just do what we can. So we take out 2 from the numerator. So we have 2 bracket 1 minus cosine square theta over cosine square theta. Okay, and then what we know is we make use of this Trigo formula here. That is sine square theta plus cosine square theta equals to 1. So sine square theta will be equals to 1 minus cosine square theta. So we replace 1 minus cosine square theta with sine square theta. So we have 2 sine square theta over cosine square theta, which is equals to 2 tangent square theta, which is RHS. Proved. Got it? So if you want, you can write this down. That is for a fact that tangent theta is sine theta over cosine theta. So tangent x is equals to sine x over cosine x. That's pretty much, oh sorry, what I'm talking about, oh my god. Tangent square theta equals to, sine square theta over cosine square theta. Actually, just now my mind was thinking about part 2 already. Yes, and so this is the one highlighted in blue. Okay, we replace this sine square theta over cosine square theta with tangent square theta. Right, let's move to part 2, shall we? Alright, 12 part 2. Hey, by the way, the photos, right, this is really uploaded from now on to the LMS, so you can print it. If you have color printer, that would be great. I'm trying to write as neat as possible. Okay, part 2. Hence, solve the equation. Do you notice that this is exactly this? So let me be lazy a bit. I'll replace 2 tangent square theta directly inside. So 2 tangent square theta equals to 10 minus tangent theta. So everyone put down your pen, look up. Whenever you see this type of question, right, you should be happy. I mean, if you reach this equation here, oh, all my Trigo expressions are all in tangent and I got a square. Then move everything to one side, making sure that the one with the square, the coefficient is positive. Because why? Because you will, later mock test, okay? Later mock test, I will choose this one. you will arrive at a quadratic equation for trigo. Okay, remember, if you see the objective is try to make, this will be the mock test later. The objective is to force out the same trigo expression within the equation. So let u be tangent theta. So we have 2u squared plus u minus 10 equals to 0. Now some school, right, your teacher will straight away factorize this out. Okay, it is not wrong. I'm doing it the easier way to accommodate to all students. Is you let u be tangent theta is a redundant step, but to me it's good for teaching because you can clearly see the quadratic equation easily. This is just a means to simplify the equation. So I will make a comment, make it easier make it neater. So some teacher will straight away factorize directly, nothing wrong. Okay, but teaching wise, I will do it this way. So we have 2u plus 5, u minus 2 equals to 0. Okay, I'll leave it to you to figure out how to factorize. This is in Sec 2. And then you solve for u. So u equals to minus 5 over 2 or u equals to 2. Okay, again, remember, we are not solving for u. Plug in tangent theta back inside. And what we're going to do here is basic angle alpha is tangent inverse 5 over 2. Now take note that this is in angle, right? So make sure your calculator is in angle mode. Is in angle, sorry, is in angle. So we have tangent inverse 5 over 2. Let me do a quick check. For myself, I would actually leave it in 3dp. This will be 68.199 degrees, or tangent inverse alpha equals to tangent inverse 2. So this will be 63.435 degrees. And here we go again, it's the same story. Tangent is negative here, right? So it will be in the second. Okay, let me draw it bigger. It will be in the second and the fourth quadrant. So here's the basic angle. Now I'm going to do it in different color. So this is in blue lah. So this will be 180 degrees minus 68.199 degrees. Okay, and then we have 360 degrees minus 68.199 degrees. Okay, and let's do the other one in purple. But before that, let me do the ASTC here. Got it? So tangent is positive, so it will be in the first and the third quadrant. So this will be 63.435 degrees, 63.435 degrees. And in purple, so first angle is 63.435 degrees, and then 180 degrees plus 63.435 degrees. Right, now we just simplify this. So this will be, okay, I need my calculator for this, give me a while. 180 minus 68.199. My answer would be 111.8 degrees, 1 dp. 360 minus 68.199. My answer will be 1 dp, okay? 291.8 degrees. So this is 63.4 degrees, 1 dp, and then this is 243.4 degrees. And then let me write the answer properly in ascending order. So theta equals to 63.4 degrees, 111.8 degrees, 243.4 degrees, and 291.8 degrees. So this is the lucky moment where the examiner is very nice. You don't have to do any add 360 or minus 360. Because if you look at by observation, right, you would see that, hey, actually, yeah, the angles itself already covers from 0 to 360 degrees already. Can? So sometimes you need to use your mathematical sensing. You will see that, hey, actually the angles are covered in the range. But if you are a bit scared, okay, if you got time, you just do the minus 360 and plus 360 over here. Okay, minus 360 plus 360. But my advice is not really required at this point. Can? Because the angles here highlighted in yellow has already covered from 0 to 360 degrees. If you don't believe me, you can go and do it yourself. Yeah, got it? So that would be the topic on simple trigonometric identities and equations.